This is the video for accelerated geometry on Unit 19 on a special section that we're going to call the absolute value functions. So your key vocabulary in this lesson is absolute value function, axis of symmetry, and vertex. By the end of this video, you should be able to answer the essential questions of how do you graph absolute value functions and how do you identify the characteristics of absolute value functions in their graphs. Going over our key vocabulary, the absolute value function is a function with some form of absolute value of x in it. The parent function, which has no transformations of the absolute value function, is f of x equals the absolute value of x. The vertex of the absolute value function is the highest or lowest point on the graph. Your axis of symmetry is the vertical line that divides the graph into mirror images. In an absolute value graph, it has to pass through the vertex. So let's start off by looking at the graph of the parent function f of x equals absolute value of x. We have it here at the right. You can see that it takes on a V shape. So unlike a parabola, which is a U shape, the absolute value has to look like a V. This bottom point here, which in this case would be our vertex, is also a minimum. Just like before with the parabola, we had the highest and lowest points was a max or a min. In a absolute value, you also have the max or the min, which is at your vertex. We can talk about domain and range using this. So if you look at the graph, your domain, which is your x values, we're not limited going left or right. So our domain would be all real numbers. Our range, however, depends on where the vertex is. So in this case, our vertex is at 0, 0. So our lowest y value would be 0, and it's above it. So it would be y is greater than or equal to 0. If we talk about our intervals of increase and decrease, we can see that if we read the graph left to right, it goes down first. So that's everything to the left of your vertex. So decrease would be from negative infinity to the x coordinate of your vertex, which in this case is 0. Increase is everything to the right of the vertex. So then that starts at the x coordinate of the vertex, which is 0, and goes towards infinity. General form for an absolute value function is f of x equals a absolute value of x minus h plus k. Where before, just like before, if you have a negative out here in front, then there's a reflection across the x-axis, which means instead of opening up, it'll open down. The a value here is basically changing your slope, so that's going to be your vertical stretch or your vertical shrink. The h value here moves it left or right, and the k value moves it up or down. And always remember that your vertex is at HK. Okay, let's put this into use so maybe some of this will make sense to us. First example says to write the equation for the following graphs and identify the intercepts, zeros, and intervals of increase and decrease, and to compare the graph with y equals absolute value of x. So first thing for the equation, we know that our general form for the equation is y equals a absolute value of x minus h plus k, where h and k are the vertex. So your first step is to identify where the vertex is. In this case, it would be at -2, -3. So this is my h and this is my k. The next piece we need is our a, which comes from the slope. I suggest you always use the right side because the right side will give you the true a value. Because if it opens down, you should have a negative for the a. If it opens up, you should have a positive. And if you use the right-hand side of the graph, you will always get what it really is. So in this case, if I pick another point on the line, say this one right here, and slope is rise over run, so I'm going up 1 and over 2. So my a value would be 1/2. And it should be positive because it opens up. And now we're ready to plug that into our equation. So we have y equals, the a value is 1/2, absolute value of x minus h, so minus a -2 really makes it a +2, and then plus k, so plus a negative is a minus. For our intercepts, We can see our y-intercept. It's where it crosses the y-axis, which in this case is at 0, -2. For your x-intercepts, you're going to keep using your slope until which time you see where it crosses the x-axis. So in this case, if I go up 1 to the left 2, I'm here. Up 1 to the left 2. Up 1 to the left 2. It crosses right here, which would be at 1, 2, 3, 4, 5, 6, 7, -8. And now do the right-hand side. So up 1 over 2, up 1 over 2, up 1 over 2 would put me right here. So that's at 1, 2, 3, 4. And then my zeros are the same as your x-intercept, so we would have x equals -8 and x equals 4. Increase and decrease, again, we're only concerned for the increase and decrease with the x-coordinate of the vertex. So it decreases first, so that's going to be from -infinity to the x-coordinate of the vertex. Increases second, so that's going to be from my vertex to +infinity. And our transformations, a is less than 1, so that's going to be a vertical shrink of 1/2. You have it moving to the left 2 and down 3. Let's try another one. So again, for our equation, we need the vertex and we need the slope. So identifying my vertex, which is right here, that's going to be at 2, 3. So that gives me my h and my k. My slope, I'm going to find another point on the graph, which looks to be right here. And to get there, I'm going down 2 and to the right 1. So my a value would be -2 over 1, which is just -2. So my equation would be y equals a, which is -2, absolute value of x minus h, so -2, and then plus k. My intercepts looks like across the y-axis at -1. So that's 0, -1. My x-intercepts looks like it crosses at 0.5 and 1, 2, 3.5. So 0.5, 0, and 3.5, 0. And our zeros would be the same as our x-intercepts, so x equals 0.5 and x equals 3.5. Increase and decrease, I'm concerned with the x-coordinate of the vertex. It looks like on the left side it's increasing first, so that's going to be from -infinity to the vertex, and then it decreases, so that's from the vertex to +infinity. For our transformations, we have a negative out front, so that tells me that it is a reflection across the x-axis. The 2 is greater than 1, so that's going to be a vertical stretch. The x minus 2 moves it to the right 2, and the plus 3 moves it up 3. Next set of examples says to graph the function, identify the intercepts, zeros, and intervals of increase and decrease, and then compare the graph with the graph of the parent function, which is y equals absolute value of x. So now I'm given the equation. In order to graph it, you need to know your vertex, which in this case is hk, so the opposite of +3 would be -3, and the k would be -1. And you need to know your slope. So my a value in this case is 2. So I'm going to graph the ordered pair -3, -1. And then my slope is 2, so I'm going to go from there, go up 2 to the right 1. And I'm going to do a couple of them on the right. Mainly because I know I need my intercept, so I'm going to go at least until I cross the y-axis. And then I'm going to do the same thing to the left, so I'm going to go up 2 and to the left 1. And then I'm going to sketch my graph. Okay, so there's my graph. My intercepts, my y-intercept looks to be at 1, 2, 3, 4, 5. My x-intercepts look to be at -1, 2.5, and 3.5. Which then tells me that my zeros are x equals -2.5 and x equals -3.5. Increase and decrease. On the left side, it's decreasing first, so that would be from -infinity to the x-coordinate of the vertex, which in this case is -3. And then increases from the vertex to the right-hand side, which is +infinity. Transformations, the 2 would be a vertical stretch. +3 really moves it to the left 3. And -1 moves it down 1. One more example. So in order to graph, I need my vertex. So in this case, my vertex would be at 5, 6. And I need my slope. So in this case, the slope is -3. So I'm going to go to 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then I'm going to go down 3 to the right. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And same thing to the left. So down 1, 2, 3 to the left 1. Left 1. Down 3 to the left 1. And then connect my points. So for my intercepts, my y-intercept looks to be at 1, 2, 3, 4, 5, 6, 7, 8, -9. My x-intercepts look to be at 3 and 7. So my zeros would be x equals 3 and x equals 7. The graph on the left side is increasing. So then that means from -infinity to the x-coordinate of the vertex, which in this case is 5. That means it has to decrease from the vertex to the right, which is +infinity. Transformations, you have the negative, so that's going to be a reflection across the x-axis. The 3 would be a vertical stretch. The -5 moves it to the right 5. And the +6 moves it up 6. And you are finished.